Yeah, welcome to this lesson. In this lesson, we'll be treating vectors, introduction to vectors. So now, we will try to explain what vectors are and see how it is used in physics. So first off, vectors, they are entities that have both magnitude and direction. So they are like the opposite of another, not really the opposite, they are like the counterpart of another quantity known as scalar. So we have vector quantities and scalar quantities. So vector quantities are those quantities that have magnitude and also have direction, while scalar quantities are those that have just magnitude but no direction. So vectors are very essential in describing a wide range of physical concepts such as force, velocity, and acceleration. So now, as I said, we have scalar and vector quantities. So the key stuffs about scalar quantities and that distinguishes it from vector quantities is that scalar just has magnitude. Example: mass, time, temperature, length. So these things they have magnitude. But if someone tells you that something has a mass of say 25 kilogram, sorry 25 yeah 25 kilogram, it has a mass of 25 kilogram, you can't tell whether the mass, they're not really telling you a direction of where that mass is acting towards, although logically you might think it is going to act downward. But when you're talking about direction, when you're adding direction downwards, you're no longer talking about the mass of that particular entity, you're not talking about the weight of that particular entity. So now, scalar quantities are those quantities that they just have magnitude but they don't have direction, while vectors are those that have both magnitude and direction. So for example, we have displacement, we have velocity, we have force. So on that scalar we have speed. Speed is different from velocity. Velocity is when you are adding direction to a particular speed. So we have under vectors we have displacement, we have velocity, we have force. So under scalar we have mass, time, distance. So the distinguishing factor between scalar and vector quantities is that both of them are both quantities, but one of them has magnitude and just without direction, while the other one has magnitude and also direction. So let's see. For vectors, after talking about scalars now, there is these vectors now, there is how these vectors can be added. They have magnitude and they have direction. So there's how we add these vectors. And that addition is what is known as vector addition. So it involves the combining of two or more vectors to produce a resultant vector. So it's like as though we have vector A plus vector B, and we're trying to join them together under addition to give us a new vector known as the resultant vector. So this can be done geometrically by placing the tail of one vector at the head of another vector when you're trying to draw it graphically. So an alternative way is to use what is known as the algebraic method to determine the resultant force of a particular vector. So when you join vectors together, adding them, you have what is known as vector addition. So vector subtraction is the opposite of that. So subtraction is just the same way it is mathematically when you're trying to take off a particular vector from another vector. So subtraction is kind of like the process of finding the difference between two vectors. So it's usually done by reversing the direction of the vector and trying to subtract it from the other vector. So alternatively, vector subtraction can be done algebraically. So both vector addition and vector subtraction, they can be done graphically, where you would have stuff like this. You could be seeing stuff like this: arrows, another arrow, you see another arrow. So these are like vectors. But now these arrows could be drawn in I think it could be drawn in these arrows, it could be drawn in terms of graph, where you would have the x-axis and the y-axis. You have the x-axis and the y-axis. Sorry about this. So we have the x-axis and the y-axis. We have the y-axis and we have x-axis. So these vectors, they can be drawn on graphs. They can be drawn on graphs like this, and we can get their subtraction and the addition graphically. But now, aside using the representation on graph, where we have the y-axis and the x-axis, aside using the representation on graph, we can also get the addition and subtraction of vectors using algebraic expression. So it's just like as though you have, let's assume you have vector A, being equal to say AI plus BJ plus CK. So when you see this IJK, they're trying to represent vectors, different vector components. So let's say that is for A, and we have B to be equal to say PI plus QJ plus RK. So for vector addition, what it just means is just you join the I components together. Sorry, you join the I components together. That's the I plus the I and the constant plus the constant. But you will not add the I. You will not really add the I because you just like as though you're collecting like terms. So when you want to solve this, you'll be having something like this: AI plus PI plus QJ plus BJ plus CK plus RK. So you've grouped them based on their similar components. So you, if it were to be numbers, you then add A plus P to get your value for the resultant vector in that particular axis. You do the same thing for this Q and B. Do the same thing for C and R. Add them together. Say we had 2, 3. So joining them together, we're having 2 plus 3 is going to be giving us 5I. As in here we add 1, 2. 1 plus 2 is going to be giving us 3J. Then here, let's say we add let's say 5, 6. 5 plus 6 is going to be giving us 11K plus 11K. So this would be the resultant vector from adding these two vectors. So on the reverse, when you're talking about subtraction, it's just as though you have your same A and B, and you're trying to take a subtraction of A from B. Since you're subtracting B from A, since subtracting B from A, you multiply through B by minus. So you multiply this by minus, all the signs will change from whatsoever they are to the opposite of what they are. So then you can now do the normal addition, so that you can now the first thing you will always do when you're trying to do vector subtraction is you would have your A, you would have your B. Then first you then go to get your B negative. So once you got your B negative is gotten by flipping the signs of everyone. So as you had maybe AI plus BJ minus CK. If you want to get the negative B of this, if this was B, say this value was B. If this was B, and I'm trying to get minus B, it should just be to change the units, the signs of each of these parameters. So A is positive here, so we'll change it to minus AI. B is positive here, so it's the same minus BJ. C is negative here, so it becomes plus CK. So this will be the reverse version. So now if you want to then add, you then add A plus minus B. So you'll be having A minus B, because that's what you'll be joining, but you just add them generally. Then whatsoever you get using normal vector addition will be your final answer for that. So that's how we do vector addition and vector subtraction. So let's move on to the next slide. On to the next slide, we have the importance of vectors in physics. So they are used for describing physical phenomena. They are used to understand the magnitude and direction of different entities, and they are also used in solving real world problems. So let's see. Vector representation. So vectors could be represented graphically. They could be represented graphically. They could be represented polarly, in polar form. They could be represented graphically. So graphically, when they are being represented, they are represented in terms of x, y, and z coordinates, which could be represented as I, j, and k coordinates. So that's how you represent vectors graphically. So in that case, you'll be having something like this, this, and this. Sorry, not that. This is, sorry, went off. So that's that and this. So we have this from center, this. So we have three axes. We have the y-axis, we have the x-axis, and we have the z-axis. So this is how they represent vector in terms of this form. It could be represented in this form, or it could be represented in terms of I, j, and k. I, j, and k, and it can also be represented in another form that is known as the Euler's method or the polar method. So when you have three-dimensional vector, that's when you have the I, j, and k components. In some cases, you might have just I and j. So, but when you have the three-dimensional vector, you would have I, j, and k. You would have I, j, and k as the different portions of the vector. So now let's move on to our next slide. In conclusion, we've tried to treat basically what vectors are and try to give contrast to the difference between vectors and scalar quantities. Then we also try to cover up vector addition and vector subtraction as simple as they are. We also try to give interpretation of how vectors can be represented in different forms, in forms of graph, in forms of I, J, and K, and even in forms known as polar forms. So that will be all for this lesson. Goodbye.